And we are live. Take it away, Rachel.
Hello, everyone. Welcome to the March edition of the Audio Programmer Meetup. Thank you so much for joining us today. My name is Rachel, and together with my co-host, Josh, we host this meetup on the second Tuesday of every month. I'm really excited for you to meet our guests this evening. We've got two wonderful discussions for you. But before we go ahead and introduce those guests, I'm going to pass over to Josh for some announcements.
Yes, thank you very much, Rachel. And it's great to have everybody here for our monthly meetup. And as always, I'd like to give a big thanks to our sponsors, Focusrite, Juice, and Sonnox for sponsoring the Audio Programmer Meetup. So thank you very much to Sonnox, Focusrite, and Juice for sponsoring. Without you, this meetup wouldn't be possible. And also thanks to everybody who's joining us for this meetup. It's been awesome. We've been doing this for well over 2 years now, and wherever you are in the world, and I hope that you're staying safe. There are a lot of things happening in the world, of course, and I'm wishing safety to all of our people who may be tuning in from Ukraine and beyond. Please stay safe, and if there's anything that we can do for you, please message me anytime. My private messages are always open, and we want to help you. So stay safe. And with that, let's talk a little bit about some audio programming. So, Rachel, who do we have coming up for our first talk?
So for our first talk tonight, what you're going to hear is a discussion on physical modeling synthesis. Now, this is going to be delivered by Dr. Michele Ducceschi, who is a lecturer at the University of Bologna in Italy.
Hello.
Good evening. We've got Professor Stephen Bilbao from the University of Edinburgh. And we've got Dr. Craig Webb, who is currently the CEO of Physical Audio. They're producing high quality audio plugins based on the research which is conducted at the research group, which is the Acoustics and Audio Group at the University of Edinburgh. And am I right in thinking that's where you all met, is the University of Edinburgh, where you're studying under the supervision of Stefan?
That's it, yeah. Craig and I were students on the master's course in 2009, 2010. So that goes back a long way now. But we came from sort of different directions. I'm more of a physicist person. I've got a degree in physics. Craig is a computer scientist. But that is the beauty of that master's course. You'll find all sorts of people in there, people that have music backgrounds, people that have science backgrounds. But we sort of mingled together at the time, and it was great. Stefan was our teacher, of course. And then, Craig went on with doing a PhD in Edinburgh. After the master's, I left and I moved to Paris for my PhD, but I kept in contact with Stefan and with Craig. And then I moved back to Edinburgh after my PhD to do some postdoctoral studies. And that is when physical audio was born, around 2016. We started out with some simple prototypes, but then we really tried to sort of see how far we could go with that, essentially.
So this came out of a project at Edinburgh called the Nest Project, which we'll talk quite a bit about soon. So, yeah.
Nice. Without further ado, let's get started.
Cool. So I thought we'd kind of start with Stefan, really, and just to kind of really explain what we sort of understand as physical modeling, as opposed to other techniques for like digital sound synthesis.
Yeah. Okay. So I'll try to cover a lot of ground pretty quickly here. So I think, like a lot of the old synthesis techniques that people know about, I probably don't need to explain, but like the earliest forms were based on, say, wavetables, where you might have like a buffer, you'd fill it with one period of some waveform, and then you cycle through it repetitively, and you generate pitch tones that way. And then people started using more of these, like to generate more complex sounds, like through additive synthesis methods. So you have like a bunch of oscillators running in parallel. And then there were other variations too, like running one oscillator into another to get you FM synthesis, for example. And so these are the techniques that developed way back, like in the 60s, early 70s. But like the whole time, like bubbling away in the background, people were also working on these other ways to generate sound, like based just on the physics of some object, whether it's a real object like a musical instrument or something imaginary, and trying to like basically simulate them to generate sound. And like, so this started way back. So the very first work was in speech, early 60s, but it just continued, and it didn't really get any traction until later, until the 80s, when computers got faster. And there was a technique called the digital waveguide method, which came out of Karma, which is the big computer music place at Stanford in the 80s. And that's sort of what made physical modeling kind of possible in real time, like in the 90s. And it led to a really great Yamaha keyboard called the VL1, which people may remember.
And the VL7 and 70 as well.
So this was like 1994. And like at that point, the computers were, it gotten even faster, and it became possible to go and do increasingly complex models of things. And that's kind of been the story ever since. Like we have these models, we tend to, work on them like out of real time for a while, and then wait for computers to catch up, and then try to do real-time versions of them. And that's exactly where we are with physical audio these days, is trying to see like how much we can get out of these models.
It can be quite a long wait sometimes. Like,
yeah, it can be like a 10-year plus wait, actually. So, but we're patient. So okay, so that's most of the potted history.
So just to interject very quickly and clarify, does this mean that you're looking to, so normally when people are creating a stringed instrument or an instrument that's based on an acoustic instrument that has strings or flutes, things like that, that those would normally be sampled, but just to clarify for people, you're talking about actually recreating this using physical modeling.
Exactly. So that's one of the big benefits actually of this way of working, is there are no samples at all. So so the codes are very lightweight, which is great. So yeah, exactly. So for a string, for example, like you'd start just on paper and write down like the equation, like that defines a string. And then from there, you continue on paper, you would develop like a computer program, like a numerical method. And then eventually you move into some prototyping framework. And finally, an audio programmer will work it into something that can become real time. So yeah, that's kind of the workflow, really.
Yeah, I would like to add a little something to what Stefan has just said. So he gave a brief history of physical modeling, but actually, that goes way back. I mean, he talked about mathematical models and mathematical equations, but if you go and see what mathematicians did in the 18th century, like the 1700s, the first model, the first partial differential equation was actually an equation that described the vibration of a string. So this idea of describing sound is actually way older than the 90s. It goes back to like a few centuries, And it was very interesting the way the whole thing developed, because there were a bunch of mathematicians back then that were arguing about what the actual physical model of the vibrating string was. And they couldn't really agree on a model, And then 50 years later, Fourier came around, the guy that, after which Fourier Theory, is named. And he was actually able to consolidate everything into one theory, which is Fourier Theory. And that is very interesting because it connects, it connects basically all the sides of the work that we do within physical audio. It connects the time domain with the modal domain or the frequency domain or the Fourier domain. And he was able to show that you can actually move from one picture to the other picture equivalently. So, regardless of the way you're looking at the problem, you can always end up with the same solution. But that has consequences in terms of how you design an instrument, because sometimes you can work in the time domain, and that is what we've been doing with the synths that you can find on our website. So derailleur, for example, or preparation, that all works in the frequency in the time domain. So you can, you have a string and you can tap at different locations, and you can go and see what happens, along the string. But then you have a different description, which is the modal description or the Fourier description, where instead of looking at the string in the time domain and in space, you discretize that in terms of resonant frequencies and modes, which can also be interesting musically, because obviously at that point you have access to, for example, the resonant frequencies and the damping ratios in the frequency domain. So, in theory, you end up with the same thing, but actually that has consequences in terms of how you design the instrument and how people will interact with it. And so I think that is sort of why physical modeling is very interesting and fascinating, because you can look at the same problem, but you can solve it in many different ways. And that will have consequences in terms of how people interact with the instrument.
Should we briefly just explain some of the sort of major advances that have gone on in physical modeling? Like we sort of briefly touched on digital waveguides and how that, and maybe we could talk about how things have advanced like since that period.
Yeah, that sounds great. It'd be great as well, I think, for people who are just starting, just to hear the difference, in your words, between time domain and frequency domain, just for people that are just starting, that may be getting familiarized to Fourier and what that actually means.
Yeah, I think, do you want to do this one, Michele? Or do you
You can go, and then maybe I can.
I was just going to say something really brief about that. Like, so that for frequency domain methods, like it's kind of like the way you might think about additive synthesis. So if you think about building up a string tone, like one partial at a time, like that's the approach you would take if you were going to use like a modal method or something. So like I don't know, if the fundamental is at 100 hertz for a string, then you'd have all these partials at 200, 300, 400, so on. And you build things up that way. But like in the time domain, like you don't care actually about that. Like all you have is an equation and you just want to solve it, So you're not actually like imposing any foreknowledge about the solution onto what you're doing. You're just working with a raw equation and solving it like directly, almost as though it's like it's a bit like graphics rendering actually. So where you're just you might be modeling, say, wave propagation on the surface of the ocean or something, and it's sort of the same thing as the time domain approach, really. I mean, they're different. They have different strengths and weaknesses. Like sometimes modal methods are like super fast and powerful, just because like for the modes, like each one is just an oscillator, and that's super cheap to compute. But then like you run into trouble sometimes, like if you have to deal with some very complicated geometry or something of an object, then it's tricky because you need to figure out, first of all, what the modes are, what all those frequencies are before you can even start. So there's just different strengths and weaknesses. Like I'm definitely a time domain person, like for the most part. Michele kind of does both actually, I think, right?
Yeah, I'm kind of a lot into these modal methods at the moment, and I'm actually developing a prototype for perhaps a new plugin that we might do with physical audio, and that is all entirely made in the modal domain or the Fourier domain. And in this case, like Stefan was saying, basically you still start with an equation, so you do have a mathematical model behind it. For example, in this case, I'm designing an instrument which has a bunch of strings, and they're all connected to a plate, and the connections are all nonlinear, so they give rise to a lot of weird resonances, and the sound is just absolutely huge. But then again, you start with the system, and what we do is that we try to write down the equations that describe this system. So you have quantities, for example, the displacement of the string and the displacement of the plate, and all these quantities are related mathematically. So you have physical models precisely that describe how these bits are connected together. So, we start from that, but then the way you approach the solution of this system it can be different. So if you work in the time domain, then like Stefan was saying, you're actually just directly solving the equations. Whereas in the modal domain, you sort of project everything onto this bank of oscillators that are the standing waves of the strings, and of the plate. But the beauty of it is that even if you start from a bank of standing waves, you can still reproduce a moving wavefront. So eventually, what you end up having is the same thing. But then, in our physical models, we place all these virtual microphones on top of these virtual instruments, so you can actually go and listen to the vibrations of a particular object at a particular location. But then the way you go about it is different, and there are pros and cons of each approach. And I kind of like Stefan likes the time domain a lot, and I like that too. But I think that the modal approach has the potential of the modal approach has sort of been overlooked recently, especially when you start having nonlinearities, that connect all these subsystems. And nonlinearities are really important because they give rise to a lot of interesting stuff. For example, pitch glides, you couldn't hear them in a string unless you had nonlinearities in it. Or, if you strike a plate, that would not sound like a gong unless you had all these nonlinearities in there, So they're actually really important from a sound synthesis perspective. But modally, this has not been done because, all these standing waves become very densely coupled when you have nonlinearities. So the efficiency of the modal approach sort of gets lost, if you add all these nonlinearities back in. But what I'm trying to do in my research as well as with physical audio is to actually see if there is an efficient way of solving all these nonlinearities. And I think, we're kind of close to cracking this problem somehow. And the demos I have, are pretty good. So I'm kind of hopeful that maybe we can go somewhere with that approach. But yeah, no, it's really fascinating. The whole process is just great. You just start with an equation and then you end up with sound. And I think that's the beauty of it,
And where do you, so one question I've always wondered when it comes to physical modeling is, where do you start? So let's say you have an instrument that you've never heard before. Let's say it's a stringed instrument and you want to model it. Where do you go first? Do you use a spectrogram, try to take a look at the frequencies that are happening over a space of time? And is that what you do, or am I thinking, is it something different?
I'll try to answer that one, because I think depending on who you'd ask, you might get different answers to that one. So like for me, like I'm much more of a kind of work with like equations and books kind of person. So I'm not really an experimentalist at all, but there are people who do that, exactly what you said, So for me, like if it's a string, like, there are equations for this. And the tricky thing is to try to find the one that's like, there's whole families of these, right? So for every possible thing you can imagine, there's like hundreds of models, right? And the trick is to find the one that's like sufficiently complex to get you the sound richness that you want, but not so complex that it like kills your CPU, So it's always like trying to find that sweet spot of the model, like the right one. But then there are other people. I think they're like even like digital musical instrument companies that prefer to work from measurements actually to try to tune things. So for example, if you're doing a digital piano, like it's probably a good idea to go and try to calibrate it against, real sounds, because there's uncertainties in the numbers that we would get out of books that they could easily address just by getting some good numbers. So yeah, it's a good question actually.
Yeah, this might be a good point actually to sort of talk about one of the other things that's sort of on this list of talking points, which is like, what is the actual point of what we're trying to do? Yeah, like on the one hand, there's trying to model like real actual instruments, maybe they historical ones in terms of Michele stuff, or just literally making up imaginary new instruments. Yeah. So I don't know, like Stefan, do you have a particular point of view on this aspect of kind of real versus imaginary stuff?
Yeah, like I'm all up for the latter of those two, actually. So that's kind of the real goal is it's not to like do an exact version of a clarinet or something, because that is like, I don't know, you're competing with, sample databases and stuff like that. And it's not like super
do you think
interesting either.
Do you think it's
on
like, it's not really worth trying to like almost compete with that, like having a big, sample library of stuff?
Well, I think like for me, it's just like not all that like interesting like to work on, so it would just get really boring, I think, to do that all day. But I think like, if you want to make money and like do a fantastic substitute for these giant sample databases and try to do that, you could, eventually I think they'll probably get there, but it's a lot of work actually. And the big problem is like, okay, it's easy for a piano, right, to do that, to build
It
these
depends on the
sample
instrument,
bases.
obviously.
Yeah.
So,
Like a piano, okay, so you have to hit it at, several different like velocities, and then, but that'll cover most of it. But then something like a brass instrument, like all the note transitions and stuff, like all the different valve configurations, there's this kind of like
so there's always this
combinatorial
kind of
explosion of the amount of data you need to represent it.
There's
So
always
it's
this
hard.
difference depending on what type of instrument you're actually trying to model. So some things kind of more naturally lend itself to just having a sample library, and that's going to sort of work okay and get you kind of the sound that you may hope to get. But in other instances, like obviously like brass models and woodwinds and stuff, there's trying to get that with samples, it's not going to happen.
Why not?
Because of the transitions. That's the main thing, trying to
like there are all these like really complex interactions. If you imagine like, okay, take the case of a brass instrument, right? Like you but you suppose you're changing notes like by changing the the valve positions, right? So like there's like questions about how fast you do that, how that is synchronized with what you're doing with your lips. And like that's what you learn as a brass player, right? When you're learning how to play, is how to synchronize all these different control streams. But like you can imagine, like every possibility there, like you'd need to be able to capture that somehow with a sample, and it's just like impossible, basically to get them all, I would say.
So I guess, I suppose that, if you look up, if you played, I don't know if you played with our instruments, but they're sort of way out there, so I think that we really try to explore like the boundaries of physical modeling, and we sort of try to detach ourselves from the idea of actually reproducing the instrument. But at the same time, the sounds that come out of our instruments are sort of real. You can sort of recognize bars and strings in there, but maybe not exactly, the string that you would hear from a guitar or a cello. It's something that sounds similar, but also sounds very different. And I think that is sort of that area that we really try to explore, because the approach that we have, which is to start from models, is actually very flexible in that sense, because you can really imagine to sort of try to push the boundaries of the models and see what comes out of it. And most of the time when we make this stuff and then we talk to musicians and sound designers, and the first thing they ask is, oh, I want to play a string that is 7 kilometers long or something, so everybody's fascinated by that idea.
You do. That's absolutely true. Like it's always the first thing.
It's always the first thing they ask. I want to play a huge instrument. But there is a reason why instruments are not that big. It's because they sound rubbish, so the dimensions actually matter. So you can try to make a very long string, but before you excite frequencies in the audio domain, it takes a while, and sometimes the result is not as exciting as the idea, but it is possible to do that somehow, and I think that with physical audio we actually try to create instruments that are sort of flexible in that sense, so people can explore them and see what sounds they get and if they're happy with it. But at the moment, we haven't really tried to replicate sounds of actual musical instruments. So I don't know if that's a good business strategy or not, but we like to do that.
I mean, I always view it as like you're kind of after like real acoustic quality to the sounds. That's like super important. And also trying to have some kind of element of like dynamic expression. Trying to, because obviously with a sampled instrument, just playing it from a keyboard, you get fixed into that very sort of static thing where it doesn't feel very alive. Whereas with our stuff, we're really trying to make the thing have some kind of actual dynamic expression. So when you play at different velocities, and you use a mod wheel, etc., it actually feels like you're playing a real instrument. That's kind of that's where we're trying to sort of get to. Yeah.
But I guess, Craig, the complicated part in all this process is how you parameterize everything in terms of a MIDI controller, right?
Yeah, so the parameter control thing could be a bit of a pain, like obviously. So there's always this thing that the models kind of start with these sort of list of parameters, and these are like physical parameters, things like tension and the radius of a string and all that kind of stuff. But actually then trying to translate that into things that you can move and control in real time can be much more complicated. Yeah, it's not always obvious like how to make that work. So for instance, like without the plate reverb, like do you want to briefly explain some of what happens with the plate reverb? That was our first plugin actually, and this goes back like 5 or 6 years now. So again, for reverbs, we thought it would be a good idea to start to develop them in the modal domain, because in this system you actually have a bunch of resonant oscillators, and they're all running in parallel. So that's pretty efficient computationally as well, because you're just solving each one of the modes independently, and then you sum up the contributions together. But then, we kind of wanted to have some dynamic aspects to it, so if you play around with our reverb, you can actually shrink the plate or make it bigger, and that works in real time. But obviously that has complications in terms of how you compute the modes and everything. So, it takes a bit of tinkering, but it is possible. The original idea was to have a plate. So we have this plate reverb, and we always wanted to be able to like drag the size of the plate around on the screen. So you have a little image of the plates, little drag handle, and actually change the size, because the dimensions of the plate are part of the fundamental kind of setup to it. But actually getting to the point where it's a real-time thing was not straightforward. So, and like in our initial versions, we were doing things like reacting to mouse up to trigger a state reset, things like that. And to actually get to the point where we can do it in real time and continuously change the size of the plate, that took maybe, I don't know, like probably 2 months of work. You spent a lot of time like working on that, trying to figure out how we're actually going to make this thing work in a real-time scenario. And these things they don't always come up in the prototyping and such. Like it's very easy to kind of prototype stuff in MATLAB as a physics simulation, but kind of forget about how it might work in a real-time scenario. Yeah, so that's always stuff that comes up like all the time.
Like I should say though on that though, like I think over the years we've learned, like those of us who work in MATLAB to do the prototyping have kind of learned how to I don't know, like target the things we do towards real time eventually. Like I think the early codes, that was certainly true. Like I might have some operation in there and Craig would be like, we can't do this.
Well, and normalization as well. That's always like,
yeah, that we sorted out.
Like,
yeah. But I think we're actually sorting that one out, So
yeah. Good. So we've actually used quite a bit of time. Should we briefly talk about the projects actually? Because they're kind of quite important. Stefan, do you want to sort of briefly talk about the NEST projects?
Yeah, okay. So I'll tell you a bit about the project that went on from, this is from 2012 to 2016. So this was a European Research Council funded project, and it was there was 12 people on it in total, I think. And it was all about like trying to explore like as many different types of physical models of musical instruments as possible, all offline. So there's no attempt to do anything in real time in that project. So we did, wind instruments, stringed instruments, keyboard instruments, percussion, and we also worked a lot in 3D, which is a thing we haven't talked about today because that's still way out of real time. But you can actually
that was my thing.
Yeah, that was Craig's sort of PhD project, but you can go and embed a physical model of something like, say, a timpani drum in a room and place virtual microphones in the room and listen to it. And those are heavy simulations even now. So
we should point out that, so that timpani drum simulation, which sounds cool because it's like a 3D thing, it would take an hour to get 1 second of sound out of it. And that was processing like on this really high-end GPU cluster. It's like NVIDIA Tesla cards and stuff.
but that was 2012, right? So
I don't think it's got much faster than that as yet.
Probably
though.
not.
It would probably still take
Yeah.
half an hour to get 1 second of sound out of this model at, you know, running at a full audio rate of like 44.1. So those are very much, yeah.
So like basically like a big part of the project was just like the raw kind of algorithm design, like trying to figure out like the math, like how to code these things. So that was like the bulk of it. And then there was a team within it that was devoted to parallelization, like working on GPU. And what we ended up with in the end was a kind of a system that like composers could log into our GPU machine and run offline jobs. So it was kind of like a 70s style synthesis, right? So they'd send in some very kind of obscure looking score and instrument description or something, and then wait, and then the sound would come out. And we did whole pieces that way. But they're really interesting, like, because you can get like, you know, multi-channel out. So we were really into like 16 channel, 32 channel pieces where you might have many microphones, like either on an instrument or in a space or something. And so we worked with a lot of composers. It was like super fun. I miss it like terribly. It was like the best time. And then once that was done, then we started looking at what parts of that could become real time. And that's how physical audio started, was looking at the kind of the, you know, the ashes of that project and trying to pick things out of it, you know. So, and then maybe Michele should talk about NEMIS then.
Yeah, I also have an ERC funded project now here in Bologna, and this is actually going into a sort of different direction because so far we said we aren't trying to do real instruments, but actually what I'm trying to do within this research project is actual historical instruments. So the idea is that you know, there are a bunch of instruments in museums all around the world that are out of point condition, and they cannot be restored because they're really old and precious. So maybe you have the signature, you know, the people that made it on the soundboard, and you can't just replace it with a different soundboard just because you want to play it, you know. So you have a bunch of these instruments like everywhere, and the idea is to make use of this digital technology that is physical modeling in order to reproduce the sound of these historical instruments. I think the idea is very valuable and very exciting, and obviously, you know, even with the pandemic, we came to realize how difficult it is even to get people in the same place together at the same time, you know. So perhaps if we could have, you know, a digital copy of these instruments, then maybe people can just download it from a website and play it. And so this idea is really, really great. But obviously here, you know, I'm trying to actually make the sound of a real instrument. And I'm talking to a lot of early music people and musicologists. And, you know, I really have to get into, you know, the tiny details here, because if it doesn't sound good, these people are just not going to like it, you know, and they just go, okay, this idea is rubbish. But, you know, I'm in Italy, and I'm talking to a lot of, you know, harpsichord makers, and I'm going to get soundboards built in this case. So I'm going to run experiments and trying to get as much information from, you know, the copies as possible. And then I'm trying to use that information that comes from the experiments with the physical models, the mathematical models. And hopefully, you know, something will come out of it that sounds interesting and reasonable. But I think that the idea is really, really powerful. And this is an alley of physical modeling that is also very exciting. And that I'm seeing a bunch of different research projects around the world that are sort of playing around the same idea. And I think, you know, we're going to see more of that in the future. So I don't know, tune in 5 years and I'll tell you how that went.
Cool. Should we ever listen to some little sound demos at this point? I think, yeah. So we have a new plugin that we released a couple of weeks ago. And so we work with a composer and sound designer called Gadi Sassoon, who's based in Milan, I think it's right. And he was part of the Nest project originally. So he did some of that kind of offline processing work, basically, with the Nest project. And he's done some little sound demos of the latest plugins. So I thought we can actually have a listen to some stuff. Okay, so this is our latest release. And this is based on physical modeling of prepared strings. So we have a model that looks like this. So we've got 2 strings, and then there's this thing which is basically a rattle. So this rattle kind of sits on the strings and sort of bounces up and down in reaction to the stuff that's going on each string. Yeah. So it's kind of like the idea of a prepared piano kind of thing. And so here's a couple of demo tracks by Gaddy. I'll just do 2 more. Cool. Okay, so yeah, that's some demos by Gadi Sassin.
How did you guys like them?
Really awesome. A lot of great feedback in the chat. A lot of people think that it sounds very fascinating. And
I should explain. So each of those is just an individual preset, basically. So I gave Gadi a beat, and he came up with a bunch of presets. And those demo tracks are basically from an individual preset, and it's him basically just playing around with the preset. So,
yeah, there is little like production on the tracks, right, Craig?
I think he did a bit of EQing, but that was about it. So the sound, basically, if you go through the presets, it pretty much basically sounds like that. So yeah.
And how long did that instrument take to build from beginning to end?
That's an interesting question, actually.
Okay, so it has a long history, that one. So the original, I'll try to keep it short. So the original version of that was coded in, well, there's a very, very old version from 2009. Which
we're talking preparation though, slightly different.
Yeah, preparation, but the whole like process of this gone all the way back there to 2009, and then there was the main version you're working from is from 2016, I think, right? Roughly, and then preparation has been a couple of years, right? Probably.
Yeah. So basically, so the original kind of MATLAB prototypes were done like 2 years ago, and they were just trying to start off with something which is very simple, which is that little animation, which is to have two strings connected together with this kind of rattle guide, and trying to work out how to do. So we were also doing a non-linear string. So one of those strings, one at the top is a non-linear string, and then the one at the bottom is linear. And so, yeah, we spent quite a lot of time kind of basically trying to figure out how to get the best CPU usage, because the CPU usage was like, yeah, it can be crazy trying to do that stuff. And the collision modeling gets very computationally expensive. So yeah, altogether, it's probably about 2 years in total, working on and off, not completely 2 years of work, but that sort of time scale. Yeah.
But I guess this instrument also shows somehow how we like to work together, right? Because there is the academic process first and the ideas that come out. We're actually pretty open about our designs. So if you look up like papers that we publish, you find pretty much everything in there, in terms of like the mathematical modeling. But then when we figured that out, the actual making of the plugin didn't take all that long, right, Craig? Because once we actually figured out how to make it fast, then you had all the knowledge to make it, and it probably took you like 3 or 4 months.
Yeah, there's always that kind of initial stage of working through the MATLAB codes. So I should explain, we always start with some MATLAB, then we try and go to some sort of basic C++ just to see roughly what it's going to look like. And then there's the next step of trying to get like actual optimized code, something that have some clue that it's going to work in real time, and trying to deal with things like vectorization on the CPU and all that kind of business. But and that's all done offline. So at that point, we're still just like writing sound to a WAV file. Yeah. But once you've got all that kind of stuff figured out, it's then, not such a great leap to actually kind of embed that in an engine. And then after that, you're just dealing with like user interface, the usual kind of nightmare stuff that actually takes a while. Yeah. So it actually, it's a good few months work to actually get everything, pulled together with the UI and the engine and MIDI control, et cetera, et cetera. So.
And who do you find are people who are most interested in these types of instruments? With, of course, I think a lot of people would think film composers and things like that.
Sound design is kind of something we do definitely target. And then, I mean, people like Gadi, he's an experimental composer. Yeah, so he's kind of like on the edge of the spectrum of dealing with electronic music. Yeah, but then he does some sound design work as well. But so it's that kind of a mixture of sound design and experimentalists, I guess. Yeah.
Where do you feel that it's going? Do you feel that it has any potential to get into the mainstream market, or will it always be experimental?
I'd kind of hope we're sort of making sort of baby steps towards getting. Yeah, obviously it's taken a while to, to get to a stage where we can actually have, professional plugins, etc. There's the whole learn and juice side of it, stuff you're familiar with. But yeah, we're aiming to have, by the time we've got like a suite of these kind of instruments, maybe some effects and that as well. Yeah, we're hoping we do try and sort of target or make them usable by, mainstream people. We're not specifically just saying, you have to be some weird out there experimental guy. But
although we like these people,
We do,
like
yeah. There are people, really.
I could completely see some style of music coming out, something like what dubstep was in the early 2010s, where you had this really far-reaching sound design that was completely different from anything else that had come before it. I could completely see some really different style of music come out using these types of instruments.
We would love that, obviously. Yeah, it's about initially making those contacts to work with interesting composers. That's what we're trying to do.
Yeah, I mean, there is also the option of like making banks of samples of these instruments, and then like manipulate the samples, in all sorts of different ways to actually use them in your music production, So there is that side that we haven't really explored yet, but it is definitely a possibility. So, techno music people out there, I'm talking to you.
Or drum and bass.
Or drum and bass.
We have a couple questions from the audience. Gabrielle asks, can you talk a little bit about the stochastic start? Difficult to model with FFT, but plausible with partials modeling. Not sure what that means, but maybe it means something to you. Maybe that was related. I apologize to Gabrielle if that was actually related to something in the moment that they had actually been discussing. But I think you were talking at the time a little bit about the nuances of acoustic instruments, the actual blowing motion or the actual finger hitting the string, and I think if I'm reading a little bit into what they're asking, it's about how do you actually create that? How do you actually model those inharmonic parts of the instrument that are not the actual content?
Well, I guess the answer there is pretty simple. You just stick as close to the physics as you can, and you just get them. They come out automatically, So for example, like if you, really quick, I'll say, like if you do like a wind instrument with holes on it, like, like if you learn how to play the clarinet or something, most of the time, like if you don't cover the holes, you're going to get squeaks and things. And like, you get the same things out of the physical model, right? And that's because you've done the modeling faithfully that you get all these kind of weird sort of effects and things, we want those, like they're desirable for us. So yeah, the answer is just like be super careful with your model, and don't just neglect things, because they might be interesting, so
yeah. Steve Dwyer had a question that was very similar to that, so I think we'll leave it at that. George has a question. Is the source code for any of the Nest project open source or available for licensing?
I think I owe George an email. I know who this is actually. So yeah, I think I wrote and said that it is not available, unfortunately. Partly because we're sort of thinking about what to do for physical audio, actually. So I think that's the answer. So no, we haven't. And I think actually most of it is geared towards running on the GPUs anyway. So I don't know if it'd be so useful. It's like very kind of weird code. Like it's CUDA, a lot of it. So I'm not sure how useful that would be to release. So I don't know. So sorry about that, George.
I had a question that may be completely off base. Are there any useful ways that machine learning can be brought into this field of physical modeling? Because one of the first things that I thought of was in my relatively small experience with machine learning, it's great for these tasks that are difficult to describe in code, but maybe something that you can demonstrate and that you can ask a model to actually imitate that for you. Has that been an approach that you've thought about or that you've tried, or do you think that I'm speaking complete rubbish and that has no useful no useful application?
No, I think you're very right. And actually, no, neural nets and machine learning are a big part of digital audio conferences these days. So until like a few years ago, you wouldn't see any paper related to like, AI or anything like that. But now if you go to DAFX, the DAFX conference, digital audio effects, you'll find at least half of the papers that have like neural nets in them. So it's definitely a big thing. There are a lot of uses for that. And I guess one of them is to sort of play with this gray or black box sort of thing, where basically you have a bunch of data coming in from like a guitar pedal or something, and then you ask a neural net to sort of replicate that. And they're really good at doing that. So if you're actually able to set up the neural network appropriately, then you'll get like a very good copy of the thing out of it, So, if you want to call that physical modeling, then I guess, yes, it's a big trend. But I guess we're kind of like on a different end of the spectrum here. So, so long as we're not really trying to replicate the sound of a particular piece of gear, we're sort of free to experiment with the mathematical models. So for us at the moment, like this kind of techniques are not part of the mix, but they might become in the...
There is that aspect of trying to use AI to sort of explore parameter spaces. Like Stefan, maybe that's something.
Yeah, that's true. Actually, like it's like for some instruments, like the very first modular network I did had like upwards of 400 parameters that you'd have to set like for each run, and it's like impossible to explore. And unfortunately, like a large part of it just sounded kind of like the same sludge. But then every once in a while, you kind of find a cool vein of sounds, like, and you have to kind of edge along this little tiny bit of the parameter space to find stuff. So I don't know, in some ways it's more like data mining than it is like machine learning, actually. Like in some way you're trying to you're like to pull out interesting like features from the space. And that's still kind of a big open problem. We don't know what to do about that one. So
Got it. To be continued. Jas asks a question that you addressed a little bit earlier, but I don't think Jas was along the ride at that point. So maybe I'll let you explain it briefly again. What do you use to perfect a model of an acoustic instrument? Is it more of an AI learning, or do you go by a regular process of FFT synthesis to get the timbre changes?
Either one, actually. Yeah, there's no FFTs in our codes. I don't think we've ever used one. Yeah, so and no machine learning. So it's just pure physics, actually. That's it. So simple answer there.
Yeah, I guess perhaps like we talk to sound designers at some point, during the process, and then they can direct us into precisely exploring the parameter space. But what we adjust is the physical parameters of the objects. So that comes into play at some point, but it's literally just more like adjusting numbers in the models rather than looking at spectra.
I had a really interesting question. Have you ever tried to work to a brief before, where somebody has actually said, "I want to make an instrument like this. It's kind of like a guitar, but kind of like a harp"? Have you ever tried to do that before?
Yeah, I've done that actually with composers back in the old days, and I found it usually like it doesn't work, but then like along the way there's some sidetrack that they get interested in, anyway. So because like I don't know, it's like the typical one is like something that speaks or something, right? That's a big one people want. They want a violin that talks or something, and then I don't know, you kind of scratch your head for a while and then give them something else, and then they change their mind. I don't know. Like it's hard. I don't know, because composers don't know what they want. Like, because I was asked like them first, like, what do you want? And they just say like, I don't know, what have you got? So they want to just be given something cool to play with, and then they'll find something, but they don't want to dream things up really so much. So yeah.
or they were, or oh, I told you she makes an appearance every meetup. Going back to what you were saying about clients, is that sometimes they want a lot of things, and sometimes those things can be conflicting. Can you make it speak, but can you make it not speak so much? Yeah. Well, it looks like we're done with questions. Anything else that you wanted to add before we wrap up the panel? Thanks so much. That was really fascinating, and a lot of people found that really interesting.
Well, thank you. That was very interesting, to be able to talk about physical modeling here. So thanks for hosting us, I guess. And thanks for, the people watching.
Yeah.
Yeah, that was great. Thank you.
Thank you. Yeah, I learned so much from that. Really interesting.
Yeah, and if you want to make a talk or have a panel proposal, you can do so as well, and you don't need to be as experienced as Stefan, Michele, and Craig. You can, even if you're in university, creating your first VST or your first research project, you could do so as well, and you can submit a proposal. I've put the link to the proposal submission in the video description below. So click into the video description and you can submit a proposal. We would love to hear your ideas. And if you're new to this industry and just making your first VST, that's great as well. We try to present people that have a wide array of experiences. Excuse me for a moment. I'll let Rachel take over while I'm getting the dog down.
Sure. I just wanted to ask, is there any like resources or books that you would recommend for someone wanting to get started with physical modeling synthesis?
Yeah, Stefan has a book. It's very good.
I do, but I actually wanted to recommend Julius Smith's. He's got online books, so he's the Waveguide master at Stanford, and he's got this huge web page, something called the Global Index, and you can just kind of dip into it and go from there. It's great, actually. I use it all the time. So
nice. Yeah, his books have helped me so much.
Oh, you know? Yeah. Okay.
Yeah.
And
I think
free
they're available,
too.
on DSP related as well, Stanford.
Yeah.
Awesome.
I'm back and the dog is calm again. So, great. Okay. Thank you very much, Stefan, Michele, and Craig. And once again, if you'd like to check out their plugins, you can check that out at physicalaudio.co.uk. And I will be sure to put the links in the description so you can check them out there. And now we can move along to our next talk. And we have a person who's an expert in many areas. And I was just checking out his website, and it's impressive the amount of things that a person can do if they maximize their time. So I'm very curious to ask him about his time management skills as well, because it seems like he's able to get a lot done in the time that he's allotted. So we have Geert Bevan, who is the software engineering and software product manager at Moog Music, and also the Linstrument principal software engineer and a maker, singer, guitarist, biker, and Kung Fu. You didn't put Kung Fu master, so I'm wondering if you've.
No, I'm not a master. No, I'm not a master. I haven't mastered. I'm just a student.
Even a master wouldn't call themselves a master. They'd say that.
No, well, actually, kind of do. Sifu. Thanks, Josh. Thanks for introducing me. Yeah. And thanks for that previous talk, guys. I thought that was really interesting. I just want to tie it back to when I was working on the Eigenharp 10 years ago. I don't remember what the time frame was. It was really interesting how just like the basic physical modeling string models could become so much more just by using a different control mechanism, just by giving them a different excitation source and being able to introduce some elements of chaos that is not computer generated, but is tied to human inputs of high enough resolution and precision. It was very exciting to see that come to life. And then later, like Roger and I discovered when we just hooked up the instrument to Logic Sculpture, who's been around since, I don't know when, like it's been around since forever. Sculpture all of a sudden sort of like opened up into new domains. Because these models can adapt to how you excite them, how you drive them, and then you get these very interesting like areas that influence each other, where you discover spaces in the sound that you can't get to with samples, like what you said, but that you can get to with these like new control mechanisms that are coming out. So it's very interesting.
Yeah, that is interesting. So what I hear you saying, if I'm interpreting you correctly, is that it's not only the instrument, but it's also the actual interaction with the instrument as well. That's important.
It is, in my opinion. I feel like that's a big part of acoustic instruments is what your human relationship is with the object that you're using, and it can be everything. It can be like I'm obviously an acoustic guitar player, but like it's like how do you rest your arm on your guitar? Like where do you position yourself in the room to hear the reflection of the sounds? Are you what types, like how old are your strings? How new are your strings? How like are you how do you file your nails when you? That's my big thing. Like how do you find your nails when you attack the strings? And do you have a little piece of skin that is there at the beginning of the attack to sort of have a little bit of dampening while you have still your like the excitation of your nail? Like all these things are part of triggering the sound. And I think we're just like at the beginning of digital audio, digital music, with like the controllers getting to a point where some of these things can be achieved.
And that's really interesting, because I think about a lot of composers, like look at producers like Skrillex, who are just able to make music on a laptop. It's like the laptop's an interface, and the way that you interact is really compelling and really contributes to a lot of the ways that decisions are made in the way that you compose a song. DAWs as well. Yeah. Yeah, that's really interesting. Where do you see these interfaces going in the future? We've jumped straight in the deep end.
I mean, I'm in the midst of it, so sometimes it's a little bit hard to sort of like peek out and look like how far the forest goes. I don't know. I feel we're just at the beginning of what all of this could be. Like we've had only a couple of years, like we had the MPE specification that we finalized, which finally sort of codified something that people were doing, but nothing was written down. So it was a little bit difficult to get the controllers and the sound sources to understand each other well. But that to me is just like opening the door to MIDI 2.0, which is really only just getting started. And like once we're in that MIDI 2.0 space, I figure like in 10 years or so, when we have like controller sources that are not limited by 7 bits, where you're not limited by like an effective usable space of maybe like 80, 90 CC messages, where everything is not like channelized in 16 MIDI channels. Like all these limiting factors, I think, are still very much imprinting what you said, like what the DAWs allow you to do, what people are able to hook up to each other, like what is understood by the different modulation matrices. Like all of these things are very much in form and limit what can happen. I feel like MIDI 2.0 can radically change all of that. So I just hope that we're getting more and more weird instruments and weird controllers out there, so that people can very experiment with these spaces, and like what you said, Stefan, like find that niche in the parameter space where, like, okay, but like if I put my palm down and then like rub with my 3 fingers on that edge of this particular digital surface, and I hook it up to that physical model, like, that sounds so awesome. Like, it would be like, I think it will get there where you're not feeling like you're limited by what the digital connections allow you to do, but where you feel free to sort of like let your emotions go and it's just this, like, disappear, find yourself disappear in that exploration.
That's amazing. And do you, and that brings me to the point that you're working with 2 companies, Roger Lynn and Moog, who have been very instrumental in how we listen to music today, with Moog synthesizer, with the Akai MPC. And how do you continue that legacy? How do you continue moving forward from where things have gone? So Moog have gone, of course, with their signature sound. How do you take that and continue the legacy and say, yes, but we can go further? How do you do that as an engineer?
It's a really good question. Moog's culture is really strong internally, and also the musicians that we work with. A big part of it, of making Moog instruments, is feeling what Moog instruments are about, and part of that is very much informed by the musicians that are using the instruments. Like, Bob was collaborating a lot, like even at the beginning, just like coming up with the first modular, with the first mini Moog, was all being like done through musicians' feedback, like collaborating with Herb Deutsch and getting all of these elements in place for actual useful musician, like allowing musicians to perform with what the engineer creates. And obviously there's a vocabulary that came out of that, which is a subtractive synthesis model, and which like the very familiar workflow of like having the oscillators going through, like with the envelope generators and the filters. Like we all know that, and then the typical Moog sound. My personal take on this is, and it's also like, it's sort of how I approach a lot of my projects, is it's often very, very hard to completely radicalize and revolutionize everything, because as a human, you're very easily overwhelmed. Like, if you have nothing that you can feel connected to, nothing that you can sort of gain a foothold with, it's way less comfortable to take a risk in other areas. So if you feel like you're completely free floating in everything that you're experiencing, might not be as comfortable to be creative with. So with the projects that I've done with Roger and then that we're doing with Moog, we just try to explore a few new elements. Like, what if we take this particular architecture and then make that more modular? What if we put it on an iPad? What if we take existing sound sources and then allow you to, like with Animal, like allow you to explore them with finger gestures? Or what if you make a traditional like Moog modular polyphonic and MIDI controllable? Like, there's just a few parameters, just a few aspects of what is known changes, and then you can also evaluate sort of like what the benefit of it is. Like, did that work? Did that actually go into something that is worthwhile exploring further? And sometimes, like, you get, like all the time, you get a lot of feedback from musicians, like, okay, well, that's interesting. Now we have more information to explore this, and we know what to explore further, as opposed to, okay, well, everything's new, so now like I don't know where to go next. So yeah, I think it's basically, we talk a lot also internally in Moog, like everyone's super passionate about synths, everyone uses the synths, but everyone still has their own preferences. We all use other gear, obviously, like not necessarily Moog gear, but also Moog gear. And then like we have our preferences, and we're sort of like riff on each other and figure out like what works well with the elements of the Moog vocabulary that we know and that people love, and sort of drive it further, like step by step, like what we did with the Moog 1. It's like first Moog poly, and like since the poly mode, like wow. Like we didn't change everything. We didn't change that voice structure, right? But still modified in certain areas, and like we have a whole digital effects section, and we get an LCD. You know, we never had like an LCD like that on a Moog instrument before. What does that open up?
Can I jump in and ask a question there?
Sure.
So you're speaking about the specific feeling of using a Moog. Could you talk a bit about what are some considerations that you make when you're translating into like a virtual analog version, in terms of like how the interface should feel, and when you're designing the interface, like how users get that feeling that you're speaking about of using the product?
It's very I'm just speaking for me, right? Like I can't speak for the Moog engineering team as a whole, how they do that. Like I just speak from my own experience here. It's very non-scientific. Like I have this memory from when working on the Model 15 app, where I had the original Model 15 sitting next to me. I had the first really well working version on an iPad Pro also next to me. And I would like go through and I was like, okay, if I turn this knob and close my eyes, even though the tactile feel is not the same, but you still get that kind of feedback loop. Like, what if I turn this knob? Does the sound generate a similar kind of emotional response in me? And what if I play notes at the same time? Does it still make me feel connected? Can I get to the places I need to get to be able to freely explore what my creativity would be? Like these type of concerns, I feel, are just as important in instrument design as like the DSP model of the sound. Obviously, like we worked a lot on that too, and there was a few things there that sort of like made it bloom open, as opposed to like initially we were modeling the modules by themselves. It's not component level modeling, but module level modeling, and things sounded okay, but somehow it sort of didn't gel, until all of a sudden we realized that we hadn't modeled the impedances between the different models, and how the actual like ports had different impedances between different outputs and different inputs. And once we started taking that into account, you got like specific like saturation characteristics that started coming into play, and like what the different ranges are of how the CV signals are controlling aspects of that particular sound module. All of a sudden, it got way closer. So there's a lot of like trying it out and sort of putting musician hat on. I'm like, okay, does this feel inspiring? And trying to sort of self-reflect. Like, it's not inspiring yet. Why might it not be inspiring? And talk about it with the other people on the team. Say, what was your experience? And cool thing is, and sometimes you come up with a completely new idea. Like, hey, what if we do this? Like, there was a few instances in Animoog Z's development. It's like, hey, what if we add this and we added that? It's like, wow, yeah, this is just like opens it up completely. Like the example there is like the Z mult. We have Z mult parameter on Animoog Z. So Animoog Z is basically the original Animoog. We took it to the third dimension. You have comets that rotate around a path and an orbit, and they were two-dimensional in the original Animoog. Now they're three-dimensional, but the timing of the Z timing was tied to the X and Y timing. So you basically just always had these planes that would just be shifting a little bit, and also sonically, you would sort of you wouldn't really feel that it was that different. And then like, okay, why are we not getting something more interesting out of it? And all of a sudden, like, oh, but we need to be able to change the timing of the Z axes also, but in relationship with the X and Y axes. And that Z mult all of a sudden opened it up, and you get these crazy shapes and also crazy modulations in the Z domain. But that only came up through experimentation, just trying it out. I was like, okay, these presets sound too similar. What is necessary? What is missing? So yeah, I don't know if that answered your question.
Yeah, for sure. Really interesting answer. Thank you.
Yeah, I think that's really interesting, and you brought up a great a great thing with the Animog, which was that you found new ways for musicians to be able to interact with with Moog and what it is as a sound or as a feeling. And I'm wondering, this is something that came from the chat as well, with a person named Along the Arc, who's a person in our chat, asking about haptic feedback and things like VR. How do you think that's going to affect the way that we interact with sound and interact with music?
Haptic feedback is absolutely essential. It's part of your own personal feedback loop. So I personally experimented with this quite a bit when I was working with the Leap Motion Controller and creating a piece of software that allows you to use the Leap Motion Controller to control synthesizers. And haptic feedback was a problem, and still is. If you're moving around in air, you lose your reference point. So what we have with physical instruments, if you always have a physical reference point. You always have something that allows you to go back and sort of self-correct whenever something happens. It's one of the reasons why playing fretted instruments is so much easier than unfretted instruments, because you've got the frets that are a physical reference point. But still, you also have strings, and you have the neck in unfretted instruments. But if you're completely in the air, that's sort of where I was going with that, but the Leap Motion Control wasn't able to support that. That's sort of what I came. That's just one realization, but I don't know if it's the right one. It's just like something that I came to is like, you can be your own reference point. And I was getting to that spot where people were asking me, how can you do gesture control and trigger notes? And you have all these like ideas that come out, like, what if you've got virtual strings in the air and you just move your hand back and forth? Like, that's cool once, but you can't really perform with that. And like, what if you have a space around yourself and you subdivide it in like pie charts, whatever, and like this section is that note and this section is that note? Well, the problem with accelerometers and gyroscopes is that they drift. So all of a sudden that space is not the same anymore. So you really don't know where you are. And the same thing like with the infrared camera with the Leap Motion, it's also not super precise and limited. So then you're like in this limited space, and like, so the next step that I was going to do, but the technology prevented it at that point, was I felt, and similar to when you play a flute was a really good example. You open and close the valves. You can be that reference point with your own fingers. You could just be mimicking in the air and say, okay, this is this note, and now it's another note, and like as if you create these combos that you play on a wind instrument. And I think that's still something that is being explored in VR. If you lose your tactile reference points, but also lose your visual reference point, and that's, again, my personal experience, I feel very lost most of the time. Like, if I would have to be creative in that space where and also you lose your sonic reference point, where you're basically free floating in virtual reality without haptic feedback and without like these reference points, I think it's hard. So I think we still have ways to go there. However, AR might be interesting. There's like some ideas that I've been like thinking about there. Well, you can still use your visual reference point, and you could still like use physical objects, but have the virtual reality overlay on top of that and sort of augment what you already know and what you're already doing. Or maybe augment the experience that the audience has so that you can have influence over non-physical visual and audio manifestations that are being generated over AR, but still using the physical world as part of your reference point, so that you can get into that feedback loop and self-correct and sort of be that in that creative mind space as a musician.
Mm-hmm. One question I wanted to ask, completely off the subject, is you have a lot of similar looking guitars back there, and I was wondering, always wondered with guitar players, what's the difference between them? In a blind test, would you be able to tell, or do they sound different?
They sound different, but they also have an emotional connection. Let's see. That first one is a guitar that my dad bought me. And it's a rootsy sounding guitar that sounds really good with open tunings. So I tuned it down a little bit. It's got this nice sort of, I don't know, rootsy, smoky kind of additional sound to it. The other one is the same brand, but I bought it as my first good guitar that I bought myself. So it's also like, oh, wow, I invested in my first great guitar. So yeah, but it's brighter sounding, more stable. It's a little bit of a bigger body. The high strings are sort of like pure sounding and can like have sort of like a bell quality to it. This Martin is like the one that's sort of behind, is the first guitar I bought when I came to the United States. So it's also like, I need a guitar when I'm in the hotel. I'm just going to leave it around at Moog, and then I'll just pick up my guitar when I stay in the hotel because I need to have a guitar. And it took me a whole day to find that. Like, just sat in the music shop here and just tried all of them out. I was like, this is the one that sounds so good. And then I have a Santa Cruz guitar over there. That's my favorite sounding one because it's got a lot of overtones. And it's also like an expensive guitar. And like, as an engineer, the first time I could afford like a really expensive guitar, it's like, okay, well, I'm attached to that. And I felt so proud that I could finally afford a guitar like that. But also, I was not planning on buying it. I actually went into the guitar shop to try out the guitar behind it, because that is a special guitar also. This one has got VO 96 mounted on it, which sort of technology that was used for the Moog guitar also, which allows for like infinite sustain on every string. And I was in Belgium at the time, and also they allow like timbral variations and arpeggio over different string sustain levels. I was in Belgium at the time, and I had backed the VO 96. I think it was a Kickstarter campaign. But I needed to order a guitar in the US that Paul Vaux would mount that in and send it to Belgium. So I needed to find a guitar that I knew existed in the US, but I could try out in Belgium. And so I went to the shop to try that one out. And then the shop owner was like, I hear you play, you should go downstairs and try these Santa Cruz. And I was like, oh my God, don't do that to me. And I couldn't get that guitar out of my head. And so, yeah. So they all have a story. They all also have a reason why I keep them around. I like playing different tunings, and it is also convenient to leave your guitar in that tuning instead of like changing between. Like, there's drop D is fine, but changing between open C and standard tuning is a lot of changing. And your lower string will sound a little bit out of whack when you go up and down for like 2 whole tones for a while. So just keeping it on that is pretty convenient.
Do you think that, because I hear a lot of attachment to those instruments in terms of the context in which you got them, and I'm wondering if will we be able to think? Maybe this is a question: do people think of software this way in the context of? Do they identify with the time and the place and the age that they got it? And do we need something physical in order to feel that type of attachment, or is it possible to feel that with a piece of software? What are your thoughts around that?
I still feel attached to like Linux, like the initial Linux installations I did from like floppy, like Slackware and SUSE. I was like, oh, like I still feel attached to Gentoo Linux and compiling everything from source. It's like it does generate with me, and I'm just talking about myself. Like it does generate an emotional response. There's a few software instruments that have that too. When like the first time I tried out Uhe Diva and heard what that could do, and that was so inspiring. Same with like Piano Tech virtual model, physical model piano from Modart. Like the first time I could hear with an MPE controller how that played the piano differently. There was a significant emotional response. So I would think yes.
Yeah.
I don't know if that's I'm curious. What about you guys? Like, do you guys have software like that?
I do. Speaking for myself, Ableton, which was the first DAW that I really felt attached to, that I could identify with and actually compose something coherent with. Right. Definitely attachment to that, and the way that works. Every time I jump into it, it just feels like the first car that you drive. It just feels so natural, and it feels like it feels like it was built for me personally.
Yeah, that's awesome.
Yeah,
and some of that kind of comes down to kind of workflow maybe as well. Like you get some kind of connection to a particular way of working. So, and that obviously that gets connected with the user interface and user experience of the software that you're using. So,
yeah, I think so. I think that there are definitely some pieces of software that I feel that I just jump into, and Massive is another one that I feel that was one of the first synthesizers that I got, and the sounds that it could produce were just amazing and beyond what anything else was able to do at the time. Still love Massive. But at the same time, I come from a DJing background as well. And there are certain ways where I feel the reverse of that. I see people that DJ on there, that can DJ on their iPad, and I think I could never do that. I'm turntables forever. even with digital final, it feels, it's good, but it's not quite the same. There are all those things that like you were talking about, the strings and the experience and all of those things. For me with DJing, it was the going to the record shop, the art on the record sleeve, the actual carrying of the crates to the clubs. And, even though I don't miss that part so much, but
it makes for a good story, right?
Yeah, exactly. It does make for a good story. It's better. It's much more. It's much more than just hitting purchase on a website, isn't it? So yeah, I think there is something to be said for both sides, for sure.
I mean, there is something, I think, to like committing. So like when you have some kind of investment, which might be time, effort, money, dedication, like some kind of commitment comes out of an investment. And I've noticed that myself when like purchasing synths on the iPad. Like I think I might have 80% of the synths out there. And most of them I only launch once, and so there's like out of interest because I'm in that space, but I barely use any of them, but I do purchase them. Even before I was like doing this for a living. So there is much less connection to these things because and that's again me. I feel part of it is because there's no effort involved. There's no like personal commitment that makes me emotionally attached to that entity. It just, like you said, I hit purchase and then now it's there, but it's also like I have to actually see it amongst the other 200 icons on that home screen. So it's there, but also not there. And so, yeah, it's an interesting topic.
Yeah.
How can we make that more tangible or more personally meaningful? You know, think about that.
Somehow I think that NFTs aren't the answer.
Don't get me started on that.
One question I wanted to ask you about is that you're a software engineer and you're also a product manager, which involves two different levels of thinking, thinking on a macro and on a micro level. As a person who dares to call themselves a little bit of a software developer and is more on the management side, I find that to be very challenging to think big picture and then to zoom in and think very small picture. How do you manage that? Do you have any advice in terms of how to switch those, or do you find it challenging as well?
It's challenging, but I also think it's part of my nature. Like, I'm just interested in all those different things. Like, I get really passionate about building the best product possible. Once the nature of a product is identified, it's like, how can this product be the best it could ever be? But this could be any nature. It could be an extremely geeky open source one file project. Like, how can this be as geeky and obscure as possible? As it could be like, how can you make the most accessible digital synthesizer on the iPad that the kid could use? Like, it could, or how do you make the best, like it's one of my personal projects. Like, how do you make the best cable holder? Like, it's just like, I get into that mindset and I sort of get obsessed about trying to identify that nature. Like, how can it be the best version of itself? And that's sort of the product manager hat. But I also, like, I like to build stuff, which is also why I do a lot of 3D printing, but coding is so convenient to build stuff. Like, you just type things and whatever you imagine can become reality, provided you figure out how to do it. And it's just so exciting with, like, well, I just did this thing and now it exists and now it becomes that, like that real product. So I think it's just part of my nature, but it's definitely challenging. It's challenging to, like, as an engineer, I want all the features, right? But it can do this and it could that and it could hook up to that and it could do like all of the things. But then as a product manager, I was like, can't do any of that. Like, what is the one thing it should do? Like, no to all these things, but how can we still make it contribute to the product? So I'm a big no guy in the product management space. I will say no by default, while my engineer will be like, no, let's do all the things. So yeah, those are usually in conflict.
Are you able, this is another question that I have that's kind of a selfish question because it's a question more for me than anything. Can you create just to create without a predetermined destination? Just to say, I'm going to go in and
no, it's horrible. Like, everything turns into a product.
Yeah.
It's like, and I used to be more like, oh, I'll just create and play like this piece of music and it's just there. I find that in the last 5 years, I was talking to my wife about this recently, like, everything is turning into a project, like, in a product. Like, just recently, like 3 weeks ago, played Hero Quest for the first time, mythical board game. Like, I'm a gamer, so like, yeah, let's play Hero Quest, and we play Hero Quest, and it's fun, it's amazing. Like, we all have a great time, and I'm like, I want to 3D print a Hero Quest board. And so I go online and I look for all the 3D printed dungeon tiles, and it's like, try them out, and it's like, but they suck. Like why don't they do this? Why don't they do that? And then I start designing 3D printable dungeon tiles. And now I'm like, oh, maybe I should make a product out of that. So now for the last 3 weeks, like my evenings have been like designing 3D printable dungeon tiles and figuring out how to like make walls with 3D sculpting software. And like, but it's in my mind, it's already a product. It's not just like, oh, I create a board for me and my buddies. No, it's like it went immediately in 2 days time from being like, oh, let's have a 3D printable board game. And then now like, should I create a Kickstarter, and which kind of video should I make, and what kind of name should it have? It's horrible. So I don't know if you're dealing with similar stuff, but yeah, no, I can't be creative for the heck of being creative anymore.
Yeah, I have a problem in that. Well, I think some people think it's a problem. I'm not sure if it is, but I can't. It's very difficult for me to pick something up, whether it's a hobby or anything, without getting really serious about it. Like if I picked up the guitar, I'd have to do guitar lessons. I'd have to get some amps and really dig into it and find out about different playing styles. Find out about the whole lineage. I'd have to go for it.
Same here. Like when I learned to drive a motorcycle, it was the same thing. Like, of course, you need to get like, it's a good idea to get motorcycle driver's lessons. But I was like, okay, but I want to do the advanced course, and I want to do this course, and I want to like, what if I do that? And like, go on the track, and like, oh, okay, I just want to drive the motorcycle to work, man. Like,
do you find that you're better at starting these things, or do you find that you're able to finish to bring these things to a finish line, or do they always just kind of start off, get to a certain point, and then they drift away, and you feel like, okay, I've expressed my I've got all the feelings out now, and I'm good. I don't need anything to do with guitars anymore.
No, I think over the last decade, I've pretty much gone towards completing everything. It's a lot of self-discipline, in that I always feel like it's kind of a shame to not like put in the daily work and to get it to a completion point, whatever that might be, so that it becomes a thing. Like, and then that's sort of going back to what you said in the beginning. Like, I have a lot of projects, but I also try to finish everything. Try to get it to a point where I'm like, now it exists and it's a thing, and then I can let go of it. Like, okay, now it's there, and I'll cycle back to it whenever it's necessary. But it also allows me to sort of like, because usually, and that's a lot of how open source works, right? You want to scratch a personal itch. It's like, there's this thing that I want to have, and I want need to do that, but nothing does it, so I'll just do it, right? And if it's never reaches that point where I feel it's to completion, I can't step back and use it. I will always be in that mindset of improving it. And that's not why I set out like on that venture. I set out on the venture to scratch my personal itch. So I want to be able to do that. I want to be able to just sit back and say, okay, now I'm a user, because it's in this spot where I feel like it's ready to be used.
And once it's ready to be used, are you able to step back and say, okay, I'm not gonna, do you feel the obligation to support, or do you feel like, okay?
It depends. It depends. Some things have a short life cycle. Some things have a, like L'Instrument has been open source in the beginning, and it comes with waves. So like, okay, let's like, are we going to add new features? And like things get into a stabilization phase, and then they just sink, and then they bubble back up. Other projects I would like to continue, but like the support, like Leap Motion stuff, like the drivers aren't there anymore from Mac. They're not supporting it on the Leap Motion side, so there's no way for me to properly support this. So I just let go. Like a recent project I did, MIDI tape recorder, it's in a state that I want it to be in, and almost get no feature requests or bug reports. So I don't feel compelled to do more, because it does the thing that I wanted it to do. So yeah.
This relates to a question in the chat from Chris Crawford asking, how do you decide what features to include in a product? Is it decided by the demographic, or are you trying to, or is it more functionality based?
For me, it usually goes back to determining the nature of the product. And it's very subjective at one point. You're like, does this respect the nature of that product? Like, will I be putting, I don't know, wings on a car? Like, it's a car, it's not a plane or no bird. Like, it would be cool if a car could fly, but it's way more than just putting wings on it. Like, that problem can be solved by putting wings on a car, right? Like, that's not how it will fly. So obviously that's kind of like a ridiculous example, but it does like happen a lot in small scale. It's like the very typical thing that just keeps popping up ever since the beginning. Ever since I started doing web design when I was in my late teens, like, can we just add a button to make it do this thing? It's like all the time, every single time that comes up. And my default now is always, no, we're not adding a button. Like, what are you trying to achieve? And like asking that question and being really honest about it often comes up, like, you find a different answer towards just adding a feature that is just amongst the collection of features. Maybe it is something that is really not necessary in that product. Maybe it is an opportunity you missed in that product, but then just shoehorning it in will not make it work. It's supposed to figure out how to make it an inherent part of the identity of that product. How can you make this feel seamless and not just bolted on? If you can't make it feel seamless, then you should, in my opinion, you should just leave it out. It's better without than with. It's better small and focused and doing the things honestly and purposefully than just being a collection of heterogeneous features that are just like this weird, like, shapey thingy.
You bring up a great point, and I can relate a lot to that, in that sometimes I feel, because I deal with a lot of clients in plugin development, and sometimes what I feel is that a product is like a song, is a statement, right? And that sometimes what I try to explain to clients is that that statement can't be, what I find is that clients want it to be every statement. They want it to be every message. They want it to be every feeling, right? And sometimes I try to explain it like, a song is a song. You just write the song. It is what it is. It makes the statement it makes. And if it's a happy song, it's a happy song. And if you want a sad song, write another song that's a sad song.
Yeah. Very true. It's very true. Yeah.
But I find that with a lot of clients is that in the beginning, they want to make a statement. Then there's a stage where they want it to be every statement. They want it to be everything. And, oh, I wish it had this feature and I wish it had this button. And there's this inevitability that it's not going to be everything, right?
I mean, you have to ask yourself the question, like what you said, like what are you making? We're basically making things that inspire people, right? We're making effects or instruments or like that allow people to be creative. People can be creative with a spoon, like you get two spoons and you tap them together and you get an amazing performance out of it, right? You can be creative by playing percussion on the table. So it's not the features that determine whether someone feels creative or can like feel emotionally attached and productive with the product you're making. It's not the features, it's their relationship with the product. So if you can't add the features in a way that makes that relationship honest, then it's going to become a tool and not an instrument. And maybe you're a tool maker and that's cool, but then you have to be honest about it. And then like you have to decide what kind of tool you're making also. And you can't have like, it's like you're going to reach for your hammer when you need a hammer. But if you have a hammer where you have all that other stuff just like dangling off and like trying to figure out how to hammer something while you have to get all that other stuff out of the way, you probably not buy that hammer. You're just like, give me the hammer so that I can hammer things. And then when I need to file something, I'll get my file. Like, I don't know, just how I look at it.
I mean, I think you always have to kind of start with some kind of clear vision of what you're trying to do in the first place. Yeah. Otherwise, you're just going to drift off into some no man's land.
And something that people often have trouble with is alienating customers. Like, I feel you should probably alienate people that don't align with that vision. Like, that's just part of it. Like, it's just like when you're building a real instrument. Like, imagine you're building a guitar and someone comes along and say, but I want to blow. Like, I'm a wind player. You're not going to say, hang on a minute, I'm going to like mount this PVC pipe on my guitar. Like, you're making it a guitar. So yeah, I mean,
yeah, one of the
someone might want to know. I was saying, it's like,
then you got a bagpipe.
Yeah, a bagpipe guitar string thingy.
Yeah, I think one of the most interesting spaces that I find really interesting are guitar pedals and what's happening in the modular world at the moment. It feels like there's a lot of creativity happening in that space, and they're quirky and they just do one thing, but that one thing is really interesting. And I've felt like plugins should go more for that. Or does one thing, that one thing is very quirky, very difficult to make that happen in a signal chain. You need that one plugin to do that thing.
It's like the Linux mindset on the computer, right? Like, you have thousands of little tools, they all do individual things, and then you figure out how to hook them up, and all of a sudden you can make them and do like almost anything you want, which then almost like, it's like programming. Like, you have a bunch of statements that you combine in a certain way, and you can make every single thing you can imagine with it.
Yeah. We're nearly out of time, but I wanted to ask you something. So as we know, you're currently looking for a software engineer for Moog.
Actually, two, but the other position hasn't opened yet. Like, yeah. So there's going to be two hires.
What makes a Moog software engineer? What makes a person the right fit for a company like Moog?
It's usually like culturally, it has to be a good fit with the rest of the team, because we really collaborate a lot. Like, it's also like a big part of everyone that works at Moog is like we humbly work together in like recognize that we can't do anything without the help of all the others that are at Moog. And that's not just people at engineering, but it's recognizing like the people on the production floor, how they bring back like how what it is like to build those instruments and how we could improve that. And people in the commercial team, how they actually talk to the customers and to the distributors and have their own experience with those customers, and these stories that sometimes like last decades, where people remember their first Moog. There's so much about humbly working together that makes the magic happen at Moog. So that's a big part of it, which is sometimes really hard, because a part of being a software engineer is sitting by yourself in front of the computer and sort of getting into your own personal mind space. And like it's sometimes a skill that doesn't like combine well with that. And then obviously someone that's passionate about music, but also like understands that technology is at the service of music, it's at the service of the product, and it's not technology for the sake of technology. So like, I'm super interested in Rust. Like, it's an interesting programming language, but I will never use Rust for a project at Moog, because I need to support it for like 10, 20 years in software land is a huge amount of time. It's one of the reasons why we only very recently started using Swift. And while we mostly still use C++ and Objective-C when it's iOS stuff. So that's also often like a little bit of something that's at odds with each other, because God, as a passionate like software engineer, you're often interested in all different types of technologies and new stuff that comes out and get excited by that. But then being totally okay with just like, okay, well, what is really necessary here? And sort of seeing the benefits of maybe not using all the language features, and maybe like not writing that incredibly amazing function that is so carefully crafted, but that no one can read unless they like spend a week with it, right? Like it's this balance to recognize that like you're building software instruments that have to last. Like Animoog just had its 10th anniversary, which is kind of a big deal for a software instrument on the iPad. Like it's 10 years, almost like a legacy instrument. So these things do come into play. So yeah, I don't know. It's just that's part of it.
Yeah, that's really interesting. I really like what you said about, it sounded like when it came to the coding aspect of it, that it's really about meat and potatoes.
Yes, and sometimes like the majority of the code is not the hard stuff. It's like once DSP is written, sometimes it's up like you spend time optimizing it, but you will not spend your whole lifetime like changing that algorithm, because that's the sound you have. You will spend your lifetime adapting it to new iOS devices, new screen sizes, new sample rates, maybe like new MIDI controllers that come out. Like you will spend that on the lifetime of your product. So it's important in order to like have a product that people feel comfortable relying upon to write it in such a way so that we can all work on it together and collaborate on it and to understand each other's code. Be humble about code reviews, be okay with pair programming, like all that sort of stuff.
You bring up a great aspect I wanted to ask you about: code reviews. Tell me about those. How are those done right? From your experience?
Well, you never have enough time to do them right, but
or how are they done wrong? That's one thing that
how they're done wrong is someone that asks for a code review and people only look for like syntactical errors and don't actually look at architecture or look for something that is fundamentally maybe problematic, because that takes like real brain cycles. Like you have to step out of what you're doing and get into the mindset of that merge request and try to identify what the nature of that merge request is, and then, okay, is that really like the purpose of what we need to do with this change? Is it like derailing other parts of the software? Is like, are there bugs? Obviously, like the worst code review for me is faking the code review, is pretending that you spent time on it, but you didn't actually spend time on it, but just like made a few comments about syntactical things and coding style things without actually spending time on it. Might as well be honest and say, hey, I don't have time to look at this. And then the way I then often do it is take a weekly meeting or something. So we have daily stand-ups and we have one weekly software engineering meeting. Take a weekly meeting to collaboratively review a chunk of code where we all take the time, set it aside, and now we're going to talk about it. So other parts that I try to do is like you have small changes that you know are less risky, that often just go by like that. But when there's things that might be more risky that have the potential of introducing architectural problems, like do these type of things, like talk them through collaboratively, as opposed to getting in that merge request and then sitting by yourself, just like commenting away, because often you also like have 10 million other things to do. So it's often hard to spend that time on it. Yeah. And the other part that I feel make things a little bit easier is to have a culture of asking for code reviews. Like, even though I'm the senior engineer, I ask for code reviews. If I write something and I'm like, this has the potential of being risky, could you guys please look at this and give me your thoughts? And then we talk about it and sort of try to instill that culture of like, I'm not this rock, like, and no one is a rock star coder that codes in their corner. Like, we're all making a product that we can be proud of and try to make it the best it can possibly be. And code reviews is a big part of that.
Great. I had two more questions and then I'll hand it to the audience for some questions.
Okay.
One question is, let's say that I was a recent graduate from a university with my computer science degree or music computing degree. I want to work at Moog. What type of projects should I be working on? What sort of things should I be doing to make myself, to give myself the right profile to potentially work at a company like yours?
I mean, I can only talk for me because like I'm evaluating the candidates for my team, right? I'm a big fan of open source. So if I can see meaningful contributions, if you can show me your GitHub page, and it's not just forks of other projects, but there is something where I can see a history of commits that you did that seem meaningful, and that go towards a purpose, and I can see that you try to make a vision come to life, whatever vision that might be. That to me already sets you apart from a lot of the other people. Obviously, someone that's in the music space, that's already a musician, like, I will be gravitating more to that type of person, because it does create it. I gotta be real, like real here. We're not in the financial sector, so like the funds available, we're also not like in Silicon Valley. The funds available to pay engineers are not prime rates. Like we like, the musical industry is not the best paid industry on the planet, like far from it. So the reality is that you have to be passionate about this to be okay with the whole working situation, and you have to find some personal purpose into like being in this space. If you are a graduate that just wants to make 6 figures immediately, and then don't go working in the music industry. Like, go into another sector, because if that's what you're about. So seeing that someone has a passion in music and is like doing some personal research and trying to get some projects to completion, that to me makes them already very attractive.
Great. A couple questions from the chat. One from Griffon Helix. I have started looking into plugin development, and I'm now wondering if CLAP will be the new standard for plugins. I've heard about this, but I've never checked it out much.
CLAP is interesting, but it's a little bit like all new technologies I was talking about. Unless majority of hosts support it, it's, in my opinion, not worth your time. And it's like a chicken and egg situation, because it might very well be. And like the guy that's creating it, I forgot his name now. He seems like an awesome, talented guy. But if nothing can host CLAP, or maybe a couple of hosts, then it's like a lot of effort for not that much gain. So yeah, maybe. Okay.
And another question from the Manuel. Are chipset features a thing in BST programming? I mean, stuff the hardware does for you in less cycles than the calculation it would take on the CPU itself. Hardware acceleration, basically.
Yeah, of course. Like Stefan said, like vectorization, trying to get neo and intrinsics in there. Like I find myself often like very privileged that like being able to focus on hardware on Apple platforms gives us access to the Accelerate framework, which is so good. Like it does vectorization and DSP calculation in such an optimized way for this platform that you kind of get a lot of things for free, but it also is made for that platform. But it allows you to have a small team to get a lot of work done that is like optimized. So yes.
Great.
Yeah,
Okay.
I can add to that. Like, I spend most of my time basically worrying about vectorization. That's
That's a big thing.
That's the key for me to get any kind of like performance basically for the stuff that I do.
Yeah.
Great.
Another big one, if you've never dealt with this, is like very clearly identify what is control rate and what is audio rate. It might be a stupid one, but a lot of people forget about it. Like not everything has to be audio rate, and if you can identify it as control rate, like sometimes it makes things a lot easier, because then you can only do that part of the calculation maybe at the beginning of your buffer, as opposed to like doing it for each sample, and then you can vectorize it and these type of things.
Fantastic. We need to run, but there's one more question that I think would be important for you to answer. Was for your job posting, is there availability for international candidates as well, or do people need to be US?
Yeah, sadly, that posting is not for like remote work. So yeah, and we like for that position, we can't also sponsor the visa. So yeah, it's only for US people.
Do they have to move to North Carolina?
Mm-hmm. Yes, for that position, yes. It's just so hard. Like I said, we have a team that really collaborates day to day together, and we get inspired by the instruments that are like the hardware instruments that are being built or designed that people don't even know yet. Like there's this magic brewing where like this weird magical cauldron thing where like you're there and someone made its first sound on a new oscillator. It's like, and it gives you ideas and you start talking about things, or people in the factory floor like are calibrating instruments and all of a sudden come up with an amazing new sound. It's like, wow, like listen to this, or like it can be anything. Like it's important. It's a big part of working together, and we firmly believe that the instruments we make at Moog can't be made by individuals. We make them as a team. Everyone collaborates on that, and it's hard when someone is remote, and certainly like even harder in a more junior position.
Yeah, thanks for that. Thank you very much.
Yeah.
For your time. Really interesting chat. And
well, thanks for having me.
Yes, thank you very much. And what I will do is, if you'd like to email me your links, I will make sure to put those in the description in the video.
Okay.
And also a big thanks to Stefan, Michele, and Craig, and also to our co-host Rachel for co-hosting. Thank you very much. Also, a big shout out to our sponsors, Juice, Focusrite, and Sonics. And if you'd like to speak at one of the audio programmer meetups, once again, this is a place for everybody. You don't have to be super experienced. This could be your first VST or research project, and we'd love to hear your thoughts and your perspectives on audio programming. I have the link in the description. It's the first link right in the description of the video. So please submit. And anything to add, Rachel?
We need to say when we're going to be back next month.
Yes. Do you know offhand?
Second Tuesday. I'm thinking the 12th of April.
I always forget.
Same time.
Yes. 12th of April. 12th of April, same time, same channel. And yeah, really feel really privileged to be here with you folks. And yeah, thank you very much. Thank you.
Thank you. Thank you.
Thank you. That was great.
Thanks for all you're doing. I think
Thanks,
Audio
Josh.
Programmer is really an amazing initiative.
Yeah.
Yes. Thank you.
Agreed.
And thank you to everybody who's tuned in as well. Thanks a lot. Please leave comments in the video and join us on the Discord, and we will see you soon.
Bye.
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 Cool.